Good morning, ma'am. Good morning, classmates. Today, I am going to report about the Gay-Lussac law and the combined gas law. Gay-Lussac's law. It is a gas law which states that the pressure exerted by a gas of a given mass and kept at a constant volume varies directly with the absolute temperature of the gas. In other words, the pressure exerted by a gas is proportional to the temperature of the gas when the mass is fixed and the volume is constant. So, the Gay-Lussac law, it is mean that the pressure is proportional to the temperature wherein the volume is remain constant. So next is the Joseph Gay-Lussac of 1808. He is a French chemist who formulated the Gay-Lussac law. Gay-Lussac's law states that the pressure of a given mass of gas varies directly with the absolute temperature of the gas when the volume is kept constant. So, this means that the temperature and the pressure is directly related or proportional to each other where the volume is constant. For example, the pressure increases, so the temperature also increases. Just like that. Next, pressure and temperature are constant. Volume are directly proportional. The relationship between the pressure and absolute temperature of a given mass of gas at a constant volume can be illustrated graphically as follows. So this graph shows the pressure increases and also the temperature increases. So they are directly proportional wherein the volume in here remains constant. Next, Gay-Lussac's law implies that the ratio of the initial pressure and temperature is equal to the ratio of the final pressure and temperature for a gas of a fixed mass kept at a constant volume. So this formula can be expressed as follows. We can see here is the P sub 1 is divided by T sub 1 is equals to P sub 2 is divided to T sub 2, where the P1 is equals to the initial pressure, the T1 is equals to the initial temperature, the P2 is the final pressure, and the T2 is the final temperature. Where in here, the P1 divided by T1 is equals to K, wherein the initial pressure divided by initial temperature is equals to constant. Next is the P sub 2 or the T sub divided by T sub 2 is equals to K. Means the final pressure divided by final temperature is equals to constant. Therefore, the P sub 1 over T sub 1 is equals to P sub 2 divided by T sub 2 is equals to K, or P1 times T2 is equals to P2 times T1. So here we have an example. The pressure of a gas in a cylinder when it is heated to a temperature of 250 Kelvin is 1.5 atm. What was the initial temperature of the gas if its initial pressure was 1 atm? So here we're going to find the initial temperature of the gas. So we have here the given, the initial pressure or the P1 is equals to 1 atm. The final pressure, the P2 is equals to 1.5 atm. The final temperature or the T2 is equals to 250 Kelvin. So as per Gay-Lussac's law, we have the formula P1 times T2 is equals to P2 times T1. So because we're going to find the initial temperature in here, so we're going to use the T1. So before that, we're going to divide both sides by P2. So we're going to cross out the P2 in here and the T1 will remain. So therefore, we're going to use the T1 is equals to P1 times T2 divided by P2. So after that, we're going to substitute the given in here. So the P1 or the initial pressure is equals to 1 atm times the T2 that is 250 Kelvin divided by the final pressure which is 1.5 atm. So after that, we're going to multiply the 1 times 250 is equals to 250 divided by 1.5 is equals to 166.66 Kelvin. Always, in Gay-Lussac's law, it is when we're going to find the temperature, it is always in Kelvin. So next is the combined gas law. Combined gas law. It combines the three gas law, which is the Boyle's law, Charles' law, and the Gay-Lussac's law. It states that the ratio of the product of pressure and volume and the absolute temperature of gas is equal to a constant. So in here, the constant is the temperature, wherein the pressure and the volume we're going to analyze or going to solve. So there are couple common equations for writing the combined gas law. The Clausius law relates Boyle's law and Charles' law to state that PV divided by T is equals to K, wherein the P is equals to pressure, V is equals to volume, T is equals to absolute temperature, or we're going to put it in Kelvin, and K is for the constant. So the next formula is the before and after, which express as this: the P1 times V1 is divided by T1 is equals to P2 times V2 divided by T2. So we have here the example. Find the volume of a gas at STP when 2.00 liters is collected at 745.0 mmHg and 25 degrees Celsius. So here we have the given. The P1 is equals to 745 mmHg, and the V1 we have 2 liters. The T1 is equals to 298 Kelvin. The P2 is 760 mmHg. The V2, where it is the unknown that we're going to solve, the T2 is equals to 273 Kelvin. So in here we see that we have the P2 that is not given in our problem, but our P2 is always be here, and it is always equal to 760. And here we're going to use this formula. The P1 times V1 is divided by T1 is equals to P2 times V2 divided by T2. But because we're going to find or solve for the V2, first we're going to cross multiply this one. So after we cross multiply, this will result into P1 times V1 times T2 is equals to P2 equals P2 times V2 times T1. So after that, we're going to divide both sides, the P2 and the T1. So we're going to cross it out. So the V2 will be left in our right side. So the formula that we're going to use is the V2 is equals to P1 times V1 times T2 divided by P2 times T1. So here it is. So after that, we're going to substitute the given values in here. So the V2 we're going to solve, or the unknown, is equals to the P1 is equal to 745 mmHg times the V1 where it is given as 2 liters, and the T2 is the 273 K divided by 760 mmHg, or it is the P2 times the T1, that is 298. So we're going to solve that one. So first we're going to multiply the P1 times V1 times T2. So 745 times 2 times 273 is equals to 406,770. And then again, we're going to multiply the 760 and the 298k, where it's resolved to 226,480. And then we're going to divide. So the result is 1.79605263 and so on. So we're going to round it off. Is equals to 1.80 liters. So next is the summary. The combined gas law shows the relationship among temperature, volume, and pressure, where it's equals to, or the expressed as this, the P1 times V1 times T1 is equals to P2 times V2 times T2.